Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 4 from the October-November 2022 Cambridge paper 3, variant 3. This is the 9709 syllabus. And this question here is about parametric equations. It says the parametric equations of a curve are x equals 2t minus tan t and y equals ln of sine of 2t for t values between 0 and a half pi. We've got to show that dy dx is equal to cotangent of t. Right, so this is a question all about what are called parametric equations. And parametric equations are equations that are defined by 3 parameters. So you have the x and the y equation, and the x and y are both expressed in terms of this third parameter. In this case, that's t. Okay, so they're not quite like Cartesian equations. These are parametric equations. Now, to find dy dx, now some of the things that I saw some of the students attempting to do, one of them was attempting to make an equation of y in terms of x, which in this case, in most cases, is not the sensible thing to do. It's not the easiest thing to do, and sometimes it makes the question quite impossible. Sometimes it's very difficult to make y the subject in terms of x. Okay, and this is one of those cases because you're going to have inverse, tan, and so on. It's going to be very difficult to make y the subject of the formula in terms of x, to make it as y as some function of x. So what we're going to do is we're going to use the technique involving the chain rule, and this is what you normally would be the easy way of dealing with such questions. So what that involves is, if you want to find dy dx, and you got things in terms of x and y, x in terms of t, y in terms of t, then you can find dy dt and multiply that by dt dx, and that gives us dy dx. Okay, so if you can find dy dt and dx dt, and then dx dt, you can write it as its reciprocal, multiply by dy dt, you got your answer. So let's start with x. So if x equals 2t minus the tangent of t. So we can find the x dt here very easily. That's going to give you 2. If you differentiate the tan of something, you get the secant squared of something. So secant squared of t. Now that's something which is in the formula book. If you weren't sure about that, that's in the formula book. So don't have to worry about that. You can find it quite easily under differentiation. It has differentiation of tan x is secant squared x. You can read it and write it down straight from there. Okay, so that's the x dt. Now we know also that y is equal to the ln of sine of 2t. Now, to find dy dt here, common mistake that people are making. First, most students got this first part right, where the ln of something. If you differentiate the ln of something, you get 1 over the same thing. So ln of the sine of 2t. Now, many of you stop there, but we have a function inside our function. Okay, so we have to use the chain rule. We have to multiply by the differential of sine of 2t. If you differentiate sine of 2t, you're going to get 2 times cosine of 2t. So we can say that our dy dt, therefore, is equal to 2 cosine of 2t over the sine of 2t. Okay, so that's dy dt. Now we have to combine them together, and we have to find dy dx by multiplying dy dt, which is this, by dt dx, which is the reciprocal of this one here. Okay, so the next step is to find dy dx, which is dy dt, which is this here, which is 2 cosine 2t over sine of 2t, multiplied by, and you got dt dx, which is basically dx dt, but upside down. So 1 over 2 minus secant squared t. Okay, so now we need to try to simplify this and make it look like become cot of t, which is a single angle. So because our objective now is to make this look like cotangent of C, which is a single angle, and here we're dealing with, in these cases, in this case here, double angles. So we're going to think of changing these into single angles. So that's one thing we have to, or we can focus on, changing these into single angles. Okay, now there's a couple of ways we could do that. Okay, so I'm going to show you two ways. One way is to take them as they are here now and say, okay, I know that cosine of 2t is the same as, if we think about it, we can change it in three ways. I'm going to bring up the formula sheet here. This is in the Cambridge formula sheet. It's not the Edexcel one. So I'm going to bring it up here. This is the formula sheet, the part that we're interested in about the trig identities. Okay, so over here, we could use one of these identities for cosine of 2a and one of the identities for sine of 2t, or sine of 2a, sorry. So what we're going to do here, I'm going to take this step by step. So the sine of 2t, we have no choice. The sine of 2a is 2 sine a cosine a, so the sine of 2t is going to be 2 times sine t cosine t. That we have no choice with. However, the cosine 2t, we do have a choice. We can change this into either cosine squared t minus sine squared t, or 2 times cosine squared t minus 1, or 1 minus 2 sine squared t. Now, I see here we have 2 minus secant squared t. Now, I know the reciprocal of secant squared t is cosine squared t. So I think it might be sensible to change this in the form where it has something to do with cosine. That might be the sensible thing to do. So I'm going to do that. So here we don't see, sometimes you don't see how you're going to get to the end until you go through some process. All right. So we're just following some logical stops right now, or steps right now. So 2 cosine 2t will be, that's going to be 2 times, and we know cosine of 2t is 2 cosine squared t minus 1. So you have 2 times 2 cosine squared t minus 1. This 2 can cancel with this 2 here. All right, so that's, I'll change the cosine 2t into 2 cosine squared t minus 1. It's changed from double to single. This is changed from double to single because we want it in the end it to become cotangent of t. All right, and now here we have times 1 over. Now, what I'm going to do here is I've changed this into cosine squared t. So I'm going to express this as cosine squared t and see what happens. So I'll have 2 minus, we know that secant squared t is the same as 1 over cosine squared t. All right. So that's like a fraction within a fraction. Let me simplify that fraction a bit. So what I'm going to do is I'm going to write this as 1 over, and this is going to be under 1 fraction cosine squared t. And that will be 2, okay, that will be 2 cosine squared t minus 1. Okay, so I've got 2 cosine squared t minus 1. I've just combined this into 1 fraction. The common denominator is cosine squared t. That has to be multiplied by cosine squared t. That has to be multiplied by 1. Okay, so I'm left with my answer. I like this. So this is multiplied by 2 cosine squared t minus 1 over, and you got sine t times cosine t. Now, what I notice is these are the same, okay? And if I do this times that, if I do 1 divided by this, it's the same as 1 times this as its reciprocal. So I can write this as cosine squared t on the numerator and 2 cosine squared t minus 1. And that's multiplied by 2 cosine squared t minus 1 over sine t times cosine t. And now we see these are the same. Right? And you got cosine t, and one of the cosine squared t's cancel out. So we're left with cosine t over sine t. And that gives us cot t. Okay, that's our final answer, cotangent t. Okay, so that's how we deal. That's one way of dealing with this question. Okay, there's also another way of dealing with it, which I'm going to show you as well, an alternative way once we got to this stage over here, we could do something else, which I'm going to show you now. Okay, so now for the next part of the question, or for alternative way of answering this question. As I said, up to here is the same. Okay, once we've got here, we can follow a different route if you want to. What we could do is we could say we know that the cosine of an angle over the sine of the angle is the same as the cotangent of the angle. So this would be like 2 times cot of 2t times 1 over 2 minus the secant squared of t. Okay, and what we can think of this as, basically 1 over, or we can think of this as, 2 over the tangent of 2t times 1 over 2 minus secant squared of t. Okay, now we know this identity here. You can see this identity is double angle identity for tan 2a. So what I can do is, as it's in the denominator, I can write this as its reciprocal. So I can write this as, here we'll have 2 times, we're using this identity here, so it's going to be 1 minus tan squared of a of t over, and we're going to have 2 tan t. Okay, and this is multiplied by 1 over 2 minus, now we have also an identity involving, which is not written here, but it's in our formula sheet, involving secant squared t. Okay, or secant squared a, which I'm going to bring. Okay, so this is the formula sheet, from the formula sheet, which really we should know anyway, but we can see that secant squared t, or secant squared theta, is 1 plus tan squared theta. So I can replace the secant squared t here with 1 plus tan squared t. All right, so we can do that. And now what will happen here is I'll leave this as, well, this 2 can cancel with this 2. So you have 1 minus tan squared of t over tan t times 1 over, now this is going to be 2 minus 1, which is 1, and minus tan squared t. All right, that's what this would become. These are the same, they've been multiplied, so they cancel out. We're left with 1 over tan t, which is the same as cotangent of t. Okay, so there's the answer to this question, done in a slightly different way from what I showed earlier. Okay, both of those ways are perfectly fine. Okay, and we've referred to the formula sheet for these identities that we needed. And that's basically the end of this question. Other questions from this particular paper can be found in the playlist that will appear in the top right of the screen at the end of this video. Other questions from the topic of parametric equations can be found in the playlist that will appear over here. Other questions which are dealing with parametric equations from my Excel collection, you'll find in this playlist over here. You can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.